Hello all, I am Dr. Rizvi and today we are starting the part 3 of this lecture, that is developing a model on RSM using central composite design. In the previous two lectures, we have already discussed that how we develop a RSM model for a set of 20 experiment with the central composite design. In the second part, we have discussed that how we feed the values of the responses after developing the 20 experiment model and how we analyze the model. We have earlier analyzed the model for the surface roughness and we have got the SMSS and lack of fit test, and both have suggested the model as 2FI, two function interaction method. In the third lecture, we will discuss how to interpret the data of ANOVA, analysis of variance, that is developed by the response surface methodology. So moving on to the ANOVA, for the present 2FI model, we will click on ANOVA and it will show these tables. This is the table of ANOVA, the two function interaction model that we have got for the surface roughness conducted on turning machine using speed, feed and depth of cut as the process parameters. Here we can see that the model F value is 14.12 and it is less than 0.0001, which shows that the present model is significant. Here you can see that below it is showing that the model F value 14.12 implies that the model is significant, and there is only 0.01 chance that this F value could occur large due to the noise. The significant factors for our model here we can decide by the p values here shown here. For each parameter having p-value less than 0.05, those parameters are considered as significant. Here we can see that speed, the parameter A, is having a p-value less than 0.05, and we can see that the interaction of A and C, that is speed and depth of cut, and BC, that is the interaction of feed and depth of cut, are having value less than 0.05. P value is less than 0.05. The p value less than 0.05 indicates the model terms are significant. So we can conclude from here that speed and interaction of speed and depth of cut, feed and depth of cut are the significant factors for the present levels that we have selected for these parameters. And these are the major crucial factors for turning operation when considering surface roughness. So these three parameters or interactions will influence the surface roughness produced by the turning operation using these three parameters with three different levels. The lack of fit value, here it is showing 4.05, which is not significant, and the chances that a lack of fit this large could occur due to noise. Lack of fit is bad. We want the model to be fit. It is showing the conclusion. You can also develop your model according to your parameters, and you can also uh, access the results. If they are coming significant or non-significant, you can have few more experiment and make the data significant according to your requirement. There is also an actual equation that is developed by design expert when you are doing experiment on a response surface methodology. Here you can see that the actual equation is shown. The final equation in terms of actual factors. The surface roughness can be represented in terms of the factors that we have selected of turning operation, that is the speed, feed and depth of cut, with the interaction of speed and feed, speed of depth of cut, and feed and depth of cut. So this is the equation that can be used to find the value of surface roughness. So that's all for this video. Thank you.